Here comes the sky.
Section 1, the big thrill. Some vocabulary we're going to look at. A lot of it is going to be review for this section, so that's nice. We have scalar, which is a quantity that only has a magnitude but no direction. Displacement, the difference in position between a final position and an initial position. It depends only on the endpoints, not on the path. Displacement is a vector quantity, so it has magnitude and direction. A quantity that has both magnitude and direction, again, is a vector. Speed is distance traveled by the time elapsed. Speed is scalar, so there's no direction. Velocity is displacement divided by time elapsed. Velocity is a vector quantity. It has magnitude and direction. Which part of the roller coaster ride produces the loudest screams? This is starting off our unit on roller coasters and theme parks in general. In the investigate, there were a lot of different things that we did. We drew out what we thought a roller coaster could look like. Some of you had really interesting ideas where you could definitely tell that the roller coaster was turning to the right. It's hard to do if you just kept it two-dimensional unless you had multiple views. So hopefully you saw a couple multiple views and some good ideas otherwise. Then we were simulating a roller coaster ride with a blindfolded person rolling around on the chair, figuring out where the parts that invoked the most emotion. And then finally we were calculating the speed of a marble rolling across a track. The average velocity is just your displacement over time elapsed. So at this point in the year, this is not a real new equation. It's just now we're talking about this being the average velocity, and that equals d over t. D is displacement, not distance. So displacement does not equal distance. They are different. They're really close to each other. They both measure how far something is, but the difference between distance and displacement would be if I were to start in Jacksonville, Florida, and take a drive down southwest for 2.5 hours, and I go to Orlando. The whole ride was 255 miles. That's my distance, because it only tells me how many miles I traveled. To make this a displacement, I would need to include a direction. 255 miles southwest. So displacement is a vector, while distance is a scalar quantity. The scalar only has the magnitude, or how much, or how big. Meanwhile, the vector has how much and what direction. For us, it's going to be useful, not if we think about north, south, east, and west, but instead if we think in terms of positive and negative directions. Or as you move on into more advanced physics, there'll be angles involved. So normally what we do is we take positive to be up and positive to be right. That would make left negative and down negative. So if my velocity after traveling 10 meters down, and it took me 1 second to do that, my velocity would be negative 10 meters per second. And that negative right there, that's my direction. So that's telling me in what direction was I going. It could be the left direction or it could be down direction. It really depends on the problem, and you would need to read a problem for some context.